Hi guys, in this episode of Shri series, we're going to be talking about precipitation reactions, all right? So I've got a question here and I'm going to take you through the process, step-by-step process on how to work through reactions that have a precipitate, all right? So in a nutshell, what is a precipitation reaction? A precipitation reaction is a reaction where one of the products formed is a precipitate, all right, or becomes a precipitate. Now, how do you identify a precipitate? Okay, so if you look at it here, you'll notice that a precipitate is characterized by a solid particle, all right? When you get a reaction, for instance, when two substances mix, you might get some solid particles aggregating below, all right? So you could say solid particles in different colors, I've seen some people make the wrong assumption that precipitates always have to be white. No, they need not be white. They could get different colors. You could get yellow, you could get green, all right, depending on the product formed, all right? So that's what a precipitation reaction is. And I mean, I'll just give you a simple a diagram, just to represent what could happen, all right? So let's say, for instance, we have a situation where we've got two reactants, okay? So I'm going to read this question out here for you. Write the net ionic equation for the reaction between silver nitrate and sodium chloride. Now, let's say, for instance, okay, we have one beaker and we have another beaker, all right? So let's say this beaker contains silver nitrate and another beaker contains sodium chloride. All right, now we know very well sodium chloride is common salt. When it dissolves in water, all right, it forms a salt solution. Now, let's say, for instance, we mix the contents. What happens at the end? So this is, before the reaction. All right. And what happens after? Okay. So let's say after the reaction. So you've mixed silver nitrate and you've mixed sodium chloride and you want to find out what happens here. You might see that there may be solid particles that settle down. Some of them are actually aggregates. That is what will give you the precipitate. All right, so this is what will happen in a precipitation reaction. You mix two aqueous solutions together and you will get a precipitate. Now, I wanted to draw this diagram to give you a rough idea, a virtual, or should I say, something that you could see, you could imagine in a lab. You've got two beakers containing two solutions, one silver nitrate and another one sodium chloride. All right, to visually illustrate what happens, and then finally you get the precipitate. Okay, now we know what will happen. So this is just a basic illustration. Let's look into the chemistry of what goes on in terms of the chemical reaction, because the question's asking us to write down the net ionic equation of this reaction. So it's important we understand what are my reactants and what are my products. Okay, so let's look at silver nitrate. All right, so if you look at silver nitrate is AgNO3 reacting with sodium chloride to form sodium nitrate and silver chloride. Okay, so we need to ask ourselves, is this equation balanced? Now, in my previous videos, I gave examples on balancing net ionic equations. So we're going to be using the same step. Is my equation balanced? I think it's balanced because the sodiums on my left-hand side and my right-hand side are the same. The nitrate on my left and right is the same. The silver on my left and right is the same. And my chlorine on my left and right is the same. The next one is very important because that will help you understand whether you know a precipitate has been formed and therefore which would be the precipitate. All right. Now, if you look at nitrates, now we know very well from our solubility rules, which I really encourage you to be very, very familiar with, because this question checks your understanding and application of solubility rules. All right. Now, if you look at silver nitrate, all nitrates are soluble. Therefore, silver nitrate is soluble, so we put aqueous there. Sodium chloride, it's basic science. You get common salt, you dissolve it in water, you will see a salt solution forming. So sodium chloride becomes aqueous too. Sodium nitrate, like I mentioned before, all nitrates are soluble. Therefore, sodium nitrate is also soluble. It forms an aqueous solution. Now, if you remember your solubility rules, all right, particularly for chlorides, all chlorides are soluble except silver chloride. So therefore, in this situation, silver chloride is actually going to form a precipitate. I would even say a white precipitate. So some people say creamish stroke white PPT to say white precipitate. All right. So you can see straight away, if you're not sure which of your products will form a precipitate, it shows that you're not very familiar with your solubility rules. All right. So this question is not really checking whether you know how to balance my equations. All right. But it's actually looking for you knowing the appropriate state symbols, because we assume when you are writing equations, it has to be balanced. You don't need to ask. You need to follow. It's a normal practice. It's a normal procedure. All right. Now, are we through with this question? I don't think so. We have written the correct balanced chemical equation, but the question's actually asking us, we need to find the net ionic equation. All right. So what do we do in a net ionic equation? We need, the right word is to ionize, to separate each compound to its respective cation and anion. It's positive or negative charge. So if you look at silver nitrate, remember the first rule when you saw the previous video on balancing ionic or net ionic equations? We ionize the aqueous solutions. So if you look at silver nitrate, what do we get? That splits to Ag plus and NO3 minus. All right? Plus Na plus and Cl minus. So you can see we are ionizing. We're splitting the aqueous substances to its respective ions. Okay? And sodium nitrate, again, that's aqueous, so it's going to be Na plus and NO3 minus. Plus, silver chloride, we don't ionize, because if you look at the basic rules of balancing net ionic equations is that you ionize only aqueous solutions and not solid. So what we get here is AgCl, which is a solid. The next step is we need to get rid of the spectator ions, because these ions, as the word suggests, they spectate. They don't take part in the chemical reaction, which in this case is the precipitation reaction. All right, so what I do here is I find which ions are common both on your reactants as well as your product sign. So you can see that there's NO3 minus there, and there's NO3 minus there, and then you've got Na plus, you've got Na plus. All right, so you can see after I remove the spectator ions, what do I get in this situation? All right, after removing my spectator ions, what I leave with is Ag plus plus Cl minus to produce AgCl solid. And that tells you that in this precipitation reaction of the formation of silver chloride, silver and chlorine take part in this precipitation reaction. Now, this reaction tells you one thing. This reaction tells you one thing. All right? And what does it say? It tells you that you know not only how to balance equations, but you know how to balance net ionic equations, and also to show what actually happens in a precipitation reaction. This reaction also shows that you're very, very familiar with solubility rules, because that is an absolutely important concept you need to understand, because in ATA exams you will inevitably get questions on precipitation reactions. You need to be familiar with that. All right, so you can see in this reaction we've shown a net ionic equation between two aqueous solutions to form a precipitate. All right, thanks for listening, guys. Bye now.